Number 23 of section 3.1, we're finding the angle beta given our surface area and our radians. And so the angle in radians is measuring how many times this radius is on this surface area. But there's a trick to this one, is that beta is actually going to be a negative number because it starts at the terminal side, the positive x direction, and goes down. So it's just similar to our previous problems where we found alpha up here, but it'll be the negative version of that. So we do the same process of beta is going to be equal to the surface area divided by radius to see how many times does radius fit into surface area. That gives us our radians, but it'll be the negative version. So I take the negative version of 3 2/5 yards divided by 4/5 yards. And the nice thing here is I have the same unit, so my units will cancel, and I'm left with a unitless version, which is radians. So radians are actually unitless. So, and you can see why here, because the units cancel out, because it's a count, how many radiuses fit into the surface area. So that's why it comes out unitless. Okay, so now for some division of fractions, I'm going to spread that out. Don't forget my negative out in front. I have 3 2/5 divided by 4/5. And to do that fraction division, I need to get improper fractions, so I get 3 times 5 is 15, plus 2 more is 17/5 divided by 4/5. And dividing fractions is easy as pie. I just flip the second and multiply. I could multiply that if I really like multiplying big numbers. Or I may notice that the 5 and the 5 actually cancel. Give me some smaller numbers to work with here. And I get negative 17/4, and that answer is in radians, which is unitless. Whoops. It's not wrong to add the radians on, so I'll just go ahead just to write that for clarity. Whoops, got in the wrong pen. But it's also not necessary.